It is April 2026, 240 kilometers into a brutal spring classic. 5.5 hours of racing. Cobbles, crosswinds, crashes, the kind of day that breaks champions and leaves them on the side of the road. And right there, at the exact moment when every human body should be shutting down, one man does something that makes no physiological sense. Tadej Pogačar attacks. Not a desperate lunge. A clean, ruthless, almost arrogant acceleration that tears the race apart like a piece of paper. And the question nobody can stop asking is this: why does he never blow up? Because here is what sports science spent 30 years telling us. After 4 to 5 hours of hard exercise, human glycogen stores are gone. The brain detects falling blood sugar and pulls the plug on the muscles to protect your vital organs. You do not decide to slow down. Your body decides for you. Cyclists call it the bonk. The French call it la fringale. Call it whatever you want. It is a metabolic shutdown, and for over a century it was considered inevitable, a law written into human biology, until someone figured out how to rewrite it. Today I'm going to take you through 120 years of sports nutrition, from rat poison in a martini glass to molecularly engineered gels, and show you exactly why the 60 grams of carbohydrate you are taking on your long rides may already be obsolete, and why what is sitting in Pogačar's jersey pocket is, right now, the single most important competitive weapon in professional cycling. Before we talk about Pogačar, we need to talk about Thomas Hicks. It is 1904, St. Louis, Missouri. The Olympic Marathon, 32 degrees Celsius, dirt roads, dust so thick that one runner was reportedly hospitalized just from inhaling it. And Thomas Hicks, who is about to become Olympic champion, has consumed almost no water during the entire race. What has he consumed? Raw egg whites and strychnine, mixed with brandy. Yes, strychnine, rat poison. The medical logic of the time was that tiny doses acted as a stimulant, wired the nervous system, and kept you moving. Hicks crossed the finish line hallucinating and barely able to stand, needing extensive medical care before anyone could call it a victory. Fast forward 50 years to the Tour de France. Riders doing 15 to 18-hour stages, scavenging food from cafes along the route. Eddie Merckx recalled eating steak, ham, and cheese before 6-hour mountain stages. In his own words, absolutely crazy. And then there was the wine. Riders performed drinking raids on roadside cafes, storming the bar for champagne and beer because alcohol was considered safer than contaminated water. There is a famous story from 1935. French writer Julien Moineau arranged for friends to set up a beer stand along a hot stage from Pau to Bordeaux. The entire peloton stopped for a cold pint, and Moineau rode on alone. And won. These are not just funny stories. They are evidence of a sport flying completely blind when it came to the most fundamental question in endurance performance. How do you actually keep the engine running? By the 1970s, scientists had finally started mapping the problem precisely. When athletes consumed a single carbohydrate source during prolonged exercise, the body could only oxidize roughly 1 gram per minute. 60 grams per hour. No matter how much more you ate, the number did not move. The intestine was hitting a hard ceiling. The American College of Sports Medicine codified this into official guidelines: 30 to 60 grams per hour. If you tried to go higher, you would end up cramped on the side of the road. And for 30 years, that ceiling was treated as biological fact. Here's the critical detail, though. The wall was never in the legs. It was in the gut. And that distinction changes everything. The bonk hits suddenly. The head drops. Coordination falls apart. Vision narrows. The pace collapses. Behind the scenes, blood sugar is crashing toward hypoglycemic levels, and the central nervous system starts shutting down motor output to protect basic homeostasis. Riders have described hallucinations, panic, an almost existential despair, and it happened to the very best. No story captures this more completely than stage 15 of the 1998 Tour de France. Jan Ullrich arrives as defending champion, leading the overall standings by over a minute, physically the most imposing stage racer of his generation. Then Pantani starts attacking on the Galibier. In cold torrential rain, without teammates, and reportedly suffering from a hunger knock, Ullrich gradually cracks. He finishes 8 minutes and 57 seconds behind Pantani. His overall lead flips to a 6-minute deficit. That face, the slack jaw, the glassy eyes, a man pedaling in a metabolic fog through freezing rain, that image became the defining photograph of everything that was wrong with sports nutrition before the revolution. A man who had everything, brought down not by a stronger rival, but by an empty tank and a ceiling that nobody had yet figured out how to break. Here's where the science gets genuinely fascinating. Imagine your small intestine is a nightclub. Glucose is the most popular customer, but there is only one bouncer at the door. His name is SGLT1, the sodium-dependent glucose transporter, and he can only let in approximately 60 grams per hour. Send more and the excess backs up, raises osmotic pressure, pulls water from your bloodstream into your gut, and suddenly you are doubled over with cramps and nausea. One bouncer, one ceiling, 30 years of dogma. And then scientists asked the question that changed everything. What if there was a second door that nobody had been using? There was. Its name is GLUT5. Fructose uses a completely different transporter to cross the intestinal wall. GLUT5 does not compete with SGLT1. They operate in parallel, handling entirely different molecules. Which means if you engineer your nutrition with both glucose and fructose in the right ratio, you can push 60 grams through one door and 60 grams through the other simultaneously. 120 grams per hour. Double the old ceiling. Not genetics, not doping, pure molecular plumbing. Research showed that mixed glucose-fructose formulas using ratios around 1 to 0.8 could push fuel delivery up to 1.75 grams per minute. That is up to 75% more fuel reaching your working muscles. Not from more effort. From a smarter fuel mixture, Pogacar's team built an entire race strategy around this discovery. UAE Team Emirates, using a product line with a 2-to-1 glucose to fructose ratio, targets between 60 and 120 grams per hour depending on stage intensity. On a hard mountain stage, reports indicate Pogacar consumes roughly 460 grams of carbohydrate on the bike over 5 hours. His total daily carbohydrate intake on those days approaches 1,200 grams. To put that in perspective, that is the equivalent of roughly 40 standard candy bars. Every single day of a Grand Tour. Let that image sit for a moment, because that number is not a boast. It is the outcome of years of deliberate physiological conditioning, and it is precisely what gives him that near-bottomless fuel tank analysts keep writing about. Now here is the part that matters for you personally, and I am going to be direct. If you go out tomorrow and try to eat 120 grams per hour because Pogacar does it, your digestive system will turn against you in ways you will not forget. The gut is a trainable organ. The intestine responds to progressively higher carbohydrate loads by upregulating its transporter proteins over time. Pogacar consumes enormous quantities of carbohydrates even on easy training days, not because he needs the energy, but to condition the intestinal architecture to handle race day loads without revolt. The practical protocol has 3 steps. Start conservative at 40 to 50 grams per hour and add roughly 10 grams every few weeks, observing your gut response. Progressive overload, exactly like strength training, just applied to your digestive system. Choose formulas combining glucose with fructose at a ratio of approximately 2-to-1. A gel containing only glucose is leaving half your available transport bandwidth completely unused. And always chase every gel with water, because concentrated carbohydrate without adequate fluid creates an osmotic pull that drags water from your bloodstream into your gut and triggers exactly the cramps you are trying to prevent. The water is not optional. It is part of the mechanism. Now here's the side of the story that does not appear in the press releases. Pay attention. During high-intensity exercise, your body redirects blood away from your digestive organs and into your working muscles. The intestinal wall starts to lose integrity. Markers of gut cell damage spike within 60 minutes of hard effort. The barrier keeping your gut contents inside your gut becomes transiently compromised. We call this exercise-induced leaky gut. Between 30 and 90% of endurance athletes experience gastrointestinal symptoms during competition because of exactly this. Not weakness, biology. Now ask yourself this. What happens when you pour 120 grams of carbohydrate per hour into a gut that is already ischemic and partially damaged? Unabsorbed sugars increase osmotic pressure. Fermentation accelerates. The intestinal lining takes on even more stress. For Pogačar, years of gut conditioning help manage this knife edge. For athletes copying elite protocols without the preparation, the risk of a severe gastrointestinal blowup is considerably higher. And the question nobody in the peloton wants to answer publicly yet is this. What does decades of this actually do to the human gut long term? The acute performance benefit is clear. The chronic arithmetic across a 20-year career is still being written. 120 years ago, Thomas Hicks won an Olympic gold medal on rat poison and brandy. 50 years ago, riders were doing wine raids mid-stage because nobody had a better plan. 30 years ago, Jan Ullrich lost the Tour de France because no one had yet figured out how to get past a single molecular bouncer in the wall of the small intestine. And today, Tadej Pogačar is attacking with 80 kilometers still to go because his team spent months teaching his gut to absorb what the human body was supposedly never designed to handle. This Sunday at Paris-Roubaix, watch the favorites when the race gets hard. Watch when they eat. They are not eating because they are hungry. They are eating to keep their brain from knowing they are dying on the inside. That is the Pogačar Protocol. Now tell me in the comments, what is the maximum number of gels you have taken in a single ride before your stomach called it quits? I genuinely want to know. And if this video made you curious about what else separates Pogačar from every other rider on the planet, go watch our breakdown of his VO2 max, titled Pogačar's VO2 Max Explained, the number that terrifies physiologists. I promise it will change how you see him. I am Sebastian from the Injury Breakdown. See you in the next one.